So what's up, guys? In this quest, we'll be talking about the families of elements. The arrangement of elements in the periodic table puts elements with similar physical and chemical properties together. It is as though the periodic table is a village, and all the elements each have their own families. The first family of elements we will discuss are known as alkali metals. The reason these elements are called alkali metals is that they react readily with water to form alkalis. The elements that belong to this family are the elements in group 1, except hydrogen. Their names are lithium, sodium, potassium, rubidium, cesium, francium. Like I said, these elements all react with water to form alkalis. But why is everyone in group 1 in this family except hydrogen? Did they kick hydrogen out? Well, first of all, these elements are called alkali metals because they react with water to form alkalis. But hydrogen is already present in water, so it does not react with water to form alkalis. Hydrogen is actually classified as a non-metal, and this is because it is able to accept an electron from most elements in the periodic table, and that is a typical behavior of non-metals. Meanwhile, let's get back to the alkali metals. The reaction with water to form alkalis is one chemical property that all elements in this family share. They are all electropositive enough to displace at least one hydrogen atom from a water molecule to form an alkali. Alkalis, as you should remember, are hydroxides that are soluble in water. All the alkali metals from lithium down to cesium go through the reaction with water to form soluble hydroxides. Another property of alkali metals is that they are all univalents, meaning that they have one valence electron. Also, they are all electropositive as they readily give away the electron in their outermost shell to form electrovalent compounds. However, as you go down the group, their electropositivity increases. This is because with the larger atoms of the elements down the group, the outermost electron is so far from the nucleus that the attractive force is very weak, so they can very easily release these electrons. This increasing electropositivity also means that their reactivity increases down the group. They go through the same reactions, but the larger elements go through these reactions more vigorously. For instance, while the reaction of lithium, sodium, and potassium with water is very fast, rubidium and cesium basically explode once they come in contact with water. These elements also react with oxygen to form oxides. Lithium, sodium, and potassium all need to be heated to form the oxides. But with other elements lower in the group, the reaction is so rapid that these elements cannot be exposed to air and remain pure. They react with oxygen from the air quickly, and if the air isn't dry, they will react with the water present as well. These elements all donate their outermost electrons to form electrovalent compounds. This way, they form bases and salts of all kinds. Their salts include chlorides, fluorides, tetraoxosulfate 6, trioxocarbonate 4s, and trioxonitrate 5s. All their trioxonitrate 5 salts, however, decompose when heated to become dioxonitrate 3 salts, releasing oxygen in the process. Their trioxocarbonate 4 salts are quite stable, except that of lithium, which decomposes to give lithium oxide and release carbon 4 oxide gas. We have explained the chemical property of these alkali metals, but what are their physical properties? What would they look like if you were to find them as pure elements and not as compounds? Well, lithium, sodium, potassium, and rubidium all exist as silvery, shiny solids at room temperature. Also, The melting point of group 1 metals decrease as you go down the group, and they have surprisingly low melting points compared to other metals. Rubidium melts at just 39 degrees Celsius, meaning that on a very hot day, it becomes liquid. Cesium and francium, on the other hand, melt below 29 degrees Celsius. This means that they become liquid at the slightest change in temperature. Whether in the liquid or solid state, these metals are very good conductors of electricity, but they are non-magnetic. They are also good conductors of heat, but their low melting points mean they can only transfer very little heat and not for very long. I hope you can remember all of these properties of the alkali metals. In case you cannot, here is a summary. All the elements in group 1, apart from hydrogen, are known as alkali metals. They are known as alkali metals because they react with water to form alkalis. They also react rapidly with oxygen as they are very electropositive. Their reactivity and electropositivity increases as you go down the group. Their melting points decrease as you go down the group. See you in the next lesson.